forum tomorrow, so somebody should help me remember. I need to announce that math lunch people can skip the line. So if people see you skip the line, you better be coming to math lunch. But we're going to make that like a standing practice because the people in the cafeteria have plenty of time to eat and wait in line. We need to eat and then do math, right? So pull out 322. If you don't have it out yet, my Math 7 people, we can get your homework for tonight done. And then tonight, or extensions or AO or whatever, you can work on catching up, right? That missing stuff that is in MAP, that is like an easier to-do list because it's in MAP. If we want to draw a diagram because it's helpful and because this doesn't always totally make sense without it. If I have 5 of something, I technically can't take 7 away, question mark, right? I have 5, but it wants me to remove 7. This is one of those situations where we add extra zeros. Every matching positive and negative is an extra 0, right? So guys, on your paper, we should be drawing out 5 pluses and then 2 zeros. And now we can remove 7, right? Because each of these right here is a 0. Does that make sense, or do we have questions about a positive and a negative are 0 together? Tell me if you got a question, because I can see it on your face.
I was just trying to count how many,
Yeah, so 1, 2, 3, 4, 5 that have no negatives under them. And then we could add as many zeros as we want. Like literally, you could add as many as you want. But now we're going to take away 7 of the positives. And it leaves us with 2 negatives that have no match. So our answer is -2.
Wait, but so we're taking even the ones that had the negatives under them?
Yeah, because the only way that we can take away 7 from 5 is by adding in extra zeros. We should swap it with a desk in Mr. Hall's room. Give him the squeaky one, since he's gone today. So -5, if we go over to B, -5 plus -7 is like start with 5 negatives and then bring in 7 more negatives. Oh, now we just have a whole bunch of negatives, really. So we just put these together, and our answer is negative. Which is a big trap door, guys. 2 negatives do not make a positive unless you're multiplying, right? So 2 bad guys team up to make a bigger bad guy team, and this comes out to be -12. What's up, Max?
Can I have a calculator charger plug you?
Oh. Yes, if I have one.
I mean, if you don't, I can always plug it into my phone.
I have them somewhere. I'm just not sure where.
Aren't those like really nice calculators?
Yeah, they're rechargeable. If we start with -5 and bring in 7 positives, we're gonna make a bunch of zeros, right? 1, 2, 3, 4. Oh crap! I'm gonna turn one of these into a 0 because I drew an extra. So 5 negatives. Right, then I bring in 7 positives. 0, 0, 0, 0, 0. Ignore this. This was a mistake.
Wait, do we need the negatives to be on top?
No, it doesn't matter. This making sense? Okay. We're just a little quiet, so I wanted to check. And we get +2. You don't have to put the plus in front of it, but you can. Minus a negative. What is minus a negative going to do? Yeah, make it a plus. Be careful. It takes both of those and makes it addition. But because it took both of these, it does make 7 positive. But what we want to be careful is that you don't think the answer is always going to be positive. It will in this case, but not always. So my note down here, I realize only makes so much sense. My note of caution. Because you have to understand what I was meaning with this. When a negative is in the parentheses, we just work with it like negative. But when we have -3, we could also rewrite this as plus -3. Because subtraction is the same thing as like adding negatives or adding debt or adding loss.
Okay, so like 3 to 4.
Here, let me come back there real quick.
Okay.
So if we put these together, 5 times -2, what's 5 times -2? Yeah, because if you have 5 sets of -2, -2, -2, -2, -2, we got 10 negatives. So you're going to have the opposite of 6. So like -6, right? So you could either write -6 or plus -6. And then the opposite of -2x. Yeah, so
So
positive.
-6 plus 2.
Yep.
I like that.
Do you not like it? Why get it if you don't like it?
It's like any of the options. And can you go over like this?
We're doing these in class. Examples from class. Remember, that's not your homework. Examples from class we do in class.
Oh, I didn't know what that even meant.
Oh, Olive, I'm just going to laugh and call that cute instead of getting upset that we've been doing this for 9 weeks.
No, I know, like, I don't know. I like know that we do it them in class. I just didn't know like.
That they weren't part of your homework. Yeah, so I've announced this a couple times to make sure everyone in here is fully, like, understanding this. Anything above where it says this is your practice work either gets done in class or is not your responsibility. It's there as examples in case you need some help to look back at. So, when you come to class this afternoon, we're going to do these, and actually we didn't have time to do these in the morning, so we'll probably do them tomorrow, but you don't need to do these right now because we're going to do it in class. Like, Katie should already have these on her paper because she already came to class.
Yeah.
So, down at 47B, let's first off change this minus to addition of an opposite. So I'm going to rewrite this and say 7.69 plus negative 2.5 times 4. So if we had 4 groups of -2.5, well, it stays negative. What's 4 times 2.5?
Would it be like 8.5?
Close. We got to go a little higher. -10, actually. 4 times 2 is 8, and 4 times 1/2 is another 2. Who's going to win here, the good guy or the bad guy? The bad guy. So we really need to like subtract and say how much bigger. Guys, work with me here for a second. Let's act like this is 8 for a moment. How much bigger is 10 compared to 8? 2. So we know the bad guy wins by 2. And then, what does this 0.69 need to get up to the 8? 31. Yeah, so this is 2.31, but it's negative because it was a bad guy, right? So negative 2.31. Flipping to the back, I doubt we're going to get all the way done with this assignment. So you go, ooh, maybe. We don't have too much more to do. How could I write out what they show me here in A as like a something equals something? How many n's do we have? 3. So 3 times n. Or you could say n plus n plus n if you really like writing out work. 3n and what? What else is on top? 10. So 3n and 10. And what do they show us? That it's... that it equals 28. Now, I can actually make this a little shorter. Like, these line up. But also, if I make this line up, like if I draw a line down, wouldn't this also be 10? So if I take 10 away from the 28, what's left for over here? 18. Yeah. I'm not sure how to pronounce it either if I don't see it. Ooh, so not cubed, not the baby 3, you want times 3. So like put a times 3, right? Not the baby one, which is an exponent. So 3 times n, so here I'll write it up here. What we are now saying is, well, 3n is 18. Right? Because we took the 10 away from both of them. We're just saying, okay, forget about that. And if 3n is 18, how big is each n? Well, Katie, you had the answer right. How big is each n? 6. Yeah, n has to be 6 here then. What about in B? What could we say there? How many x's? 2 x's. What do they equal? So how could we... Can I minus an x? Like, am I allowed to, like... Can you do 7 minus x? I don't think so. Yeah. In a minute it is. Yeah, I got you. Don't worry, I'm trying to get done as much as I can. So you should try to squeeze out one more problem too. This entire thing is 2x, but I want to break it in the middle. If we break something in the middle, what's another way to say that? In half, right? We need to do half. So what we're actually going to do is divide by 2 to do the like half. Or, I mean, you could do times 1/2 if you want. And we're going to get x is 3.5. We are out of time, though, because it is time to head back from lunch. So your advice on the next one is make sure you set up common denominators. Make sure you set up common denominators. If you want some help on 50 really quickly, we could write the first step on 50. But everyone's packing up. All right, I'm going to go ahead and put it in the video. So, guys, if you want some help with 50, go and reference the video because I'm going to post this on my YouTube. But, hey, look up at the screen and help me with this really quickly. If I walk around this shape, right, to get the perimeter, I'm going to pick up a 3 and an x and a 3 and an x. So I really got 2 x's plus 6. The area of it, how do I do area? Yeah, the area is going to be the length times the width, so like 3 times x. And then, to solve these, you substitute what they tell you for x into these expressions. Hold on just a second. Let me just... Here, keep watching this. So then what we do is, like for a, we're going to make x 5. So what if it was 2 times 5 plus 6? Or what if it was 3 times 5? So we solve these. That would be 10 plus 6 is 16. 3 times 5 is 15, and this would have to be units squared because its area. Perimeter is just units. Alright, only slightly weird. We're going to finish up this video. I lost my math lunch people. But we were right here talking about substituting in for perimeter and area, so I figure I might as well finish that problem, and then we will go back to 49. So when we're looking at perimeter and area here, we said the area inside is 3 times x because length times width. The perimeter is 2x plus 6 because when we walk around the outside. So we solved for what if x was 5. I'm not just talking to myself, I'm making a video. So what if x is 9? We then substitute in, I'm going to use a different color here. So B says what if x is 9, right? So if x is 9, then we do perimeter is 2 times 9 plus 6, and area would be 3 times 9. So area comes out to be 27, like we said, units squared. Perimeter, we got some math to do. It's going to be 18 plus 6, or 24, and we would label that just units. And then 4.6 is going to be a little bit more difficult. We probably got to grab a calculator for that, but again, we'll do 2 times 4.6 and then add 6 to it, making sure we do order of operations correctly. And then we would do 3 times 4.6 when we substitute that in. 49, like we said, the caution here is to make sure that you're using common denominators, which conveniently in A, we already have common denominators. So all we really need to do there is subtract away 7 from 11, which I believe becomes 4. If you'd like to reduce 4/12 to practice that reducing, we can divide by 4 on top, divide by 4 on bottom, and we get 1/3. So really, this would reduce down to 1/3 if you felt like it. In B, we check out our denominators, and we got a 2, an 8, and a 4. We know those won't work together, but they are kind of nice with each other. To my 2, we're going to multiply by 4 on top and bottom. And to my 3/4, we're going to multiply by 2 on top and bottom to get those denominators to all get to 8. We don't need to do anything with the 8. So if you're thinking about multiply everything like way bigger, that you can, but this is probably the easiest way. So we get 4/8 plus 1/8 plus, make sure you multiply that numerator, 6/8. That's a mistake I make a lot. 6 plus 4 plus 1 is 11/8, and there we go. And in C, probably the toughest one, at least in terms of the denominator, 6 and 4 don't really work nice together, but they do have a common value that we can find without trying too hard. You could either take this value up to 12 or up to 24. 24 is probably the one that you're going to think about in your gut, because 6 times 4 is 24. So I'm going to solve it that way, even though it's a little bit bigger than it needs to be. The other option would just be to turn 6 into 12 and turn 4 into 12, which we could definitely do, and that would be a common denominator. So if we default to multiplying by the other denominators, that'd be times 6 times 6 times 4 over 4. So this is 18/24 minus 4/24, which gets us 14/24. And like we said, we could have used 12 as the denominator, and if we had used 12 as the denominator, you would have gotten 7 as your numerator. All right, so I believe that's everything from 322. Yeah, let me know if you got questions.